Okay, so the topic for today will be differentiation, specifically the quotient rule under differentiation. I think lots of people tend to struggle with that, and we're going to dive into a question a bit later. But first, before I even talk about that question, right, what is the quotient rule? To illustrate that, let me give you an example. Let's say we have something like y is equal to p over q. Okay, this is what we call a rational function. Okay, you can think of p and q as like this combination of x's. So it can be like x squared, ln x, e to the power of x, okay, anything. Okay, and let's say now we wanted to differentiate this y, right? We wanted to find dy dx. Okay, so here's the interesting thing about fractional functions like this. We can easily differentiate it using what we now call as the quotient rule. Okay, it's basically a formula, and it goes something like this. This derivative is equal to p prime q minus p q prime over q squared. Okay, and when I say prime, by the way, it just means the derivative of something. So p prime in this case just means the derivative of p. Okay, so that's pretty much it. You have the p, you identify that. You have the q, you identify that. Find the corresponding derivatives and then plug into this formula. Essentially, that's it. Okay, I mean, just to give you an example, we can try. Let's say we had y is equal to x squared over x cubed plus 1. Alright, and let's say now the question is, what is dy dx? Right? Pretty straightforward question. So what do we do here? We know it's a rational function, which means it's in a fraction, and we can use the quotient rule. And in order to even apply the quotient rule, what do we do? Let's first identify what's p, identify what's q, and then after that find the derivatives and then plug into this whole thing. Right? So in this case, p is equal to x squared, since it's the thing at the top. Then q is equal to x cubed plus 1. Okay, then finding the derivatives of p and q. Okay, again, why we're doing this is because we're inputting that later into this quotient rule formula, right? So p prime will be using the power rule. Again, we're dropping the power down, and then we're going to minus the power by 1. Okay, becomes 2 to the power of x, 2x to the power of 2 minus 1. Okay, which is essentially just 2x. We can do the same thing for q prime. You can drop the 3 down, becomes 3, and then 3 minus 1, the power is now 2. As for the 1, right, remember that when we derive any constant, it's just 0. Okay, so this is essentially the same thing as plus 0 or just 3x squared. Okay, so now derivative time, we want to find dy dx. Okay, so we know all of this information already, so now it becomes pretty straightforward. It's all about plugging into the formula, essentially. Okay, so dy dx is equal to, let's see here, p prime 2x times q, which is x cubed plus 1, minus our p, which is x squared, times q prime, which is our 3x squared, all over q squared. Okay, it's as easy as that. And our q squared will be x cubed plus 1 square. Okay, I mean, I'll leave it to you as an exercise as to how you're gonna expand this out. Okay, but the important part here is like how you apply the formula, and it's very, very simple. Kabish? Okay, so now that we have a basic understanding of how the quotient rule works, we're gonna go into an actual question. But actually, before you even start, I encourage you to pause the video and try for yourself. See if you can solve the question now that you have somewhat of an understanding of the quotient rule. Give you 5 seconds. 5, 4, 3, 2, 1. 0.5. Okay, let's start. given that y is equal to ln 2x squared plus 1 over x plus 2, find dy dx. Okay, so immediately what comes to your mind? It should be the quotient rule, right? I mean, I see a fraction over here, I see p over q. Let's use the quotient rule. Okay, and so again, let's do the same process. Let's identify what's p, what's q, and then find the derivatives of both of them, and then input that into our trusty formula for the quotient rule, which again, if you remember, was p prime q minus p q prime over q squared. Okay, right. What is p? P will be ln 2x squared plus 1. Okay, that's the first thing I see on top, is the numerator. Q, okay, again, pretty straightforward, will be x plus 2. Let's find the derivative of both of these. Q, the derivative of q will just be x. Okay, you can treat this as x to the power of 1, right? If you do the power rule on this, the 1 goes down, becomes 1x, which is the same thing as x, and then 1 minus 1. Okay, this turns out to be x to the power of 0, or just 1. Okay, a good thing to know is that the derivative of just x is just 1. Next is the trickier part. We have ln 2x squared plus 1. Okay, if you know how to derive ln x, okay, then it would be pretty straightforward. But now we're dealing with ln and some complicated stuff inside, right? This is where you would use something called the chain rule. Okay, I didn't go over it before, but I might talk about this in another video. But the best way to think about chain rule is to actually just think about what's first on the outside, right? I don't care what's on the inside first. Okay, I'll think about it later. But what's on the outside? Okay, what do I see? It's the ln, right? And how do I differentiate ln? You just put 1 over whatever's inside. Okay, so let's do that first. If I want to find the derivative of this, I look at the ln, the first thing I see outside, and so that becomes 1 over 2x squared plus 1. That is the first part. Then, once you have differentiated with respect to whatever is outside, you just need to differentiate everything inside and then multiply it. Okay, so now basically what I'm doing here is I'll differentiate everything inside, which is differentiating 2x squared plus 1. Okay, and this is pretty manageable, right? This is your basic product rule. I mean, it's not product rule, but your power rule. So what does this become? This becomes 2x squared plus 1 times 2 goes down. So you get 2 times 2 to the power of x of 2 minus 1, which is just 1. Okay? And then plus 0. We don't really care about the 1 here. If you derive a 1, it just becomes 0 because it's a constant. Okay? So now simplifying this a little bit, we get 4x over 2x squared plus 1. Great. We now have our p, we have our q, we have our q prime, and we have our p prime. Okay, now again, like I said before, we're substituting. Let's look at the formula. How do we do this? We just need to do dy dx is equal to p prime, which you know as 4x 2x squared plus 1, okay, brackets, times q, which we know as x plus 2, minus p, which is ln 2x squared plus 1 times q prime. Okay, but q prime, if you remember, is just 1, right? So everything times 1 is just this thing again, essentially. Okay, and then this entire thing, we want to be dividing it by q squared. Okay, q squared will be x plus 2 square. Great. Let's simplify this a little bit. Okay. What I'm gonna do actually is just to split this fraction into two. So this is the same thing as 4x over 2x squared plus 1 times x plus 2 over x plus 2 squared, and then minus the thing on the left hand side, which is 2x squared plus 1 over x plus 2 squared. Okay, and then if you notice, there is a common factor in this left hand side fraction, right? Do you see it? It is the x plus 2, x plus 2. Okay, so I can cancel out the x plus 2 here, and the x plus 2, or at least the power of it. Okay, I'm canceling out one of them, and as a result, my final thing will look like 4x over 2x squared plus 1 over x plus 2 minus ln 2x squared plus 1 over x plus 2 squared. Okay, I don't think there's any need to simplify this further because, yeah, there's not really much you can do after this, honestly. Okay, great.
Brr brr patapim, il mio cappello è pieno di slim. Nel bosco fitto e